So this is Algebra 1, Semester 1. It's a unit called Graphing Linears. Linears are another word for lines. And it's the third unit. And it's the sixth lesson within this called Linear versus Nonlinear. So this is on CreatorMathcom. It's under the Algebra 1 tab. You might have to Google CreatorMath.weebly.com in Google to find the right site. Then the instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. So just to model what that looks like, because it can be difficult for students to find those notes. Sorry for the delay. So this is the name of the website, CreatorMath.weebly.com. Type that into Google. You should be able to get to this homepage. If it's any question on the composition book, students are always asking, how do I do this composition book? What goes where? All those things, right? Scroll down on this homepage until you see the words composition book. Follow all of these directions, watch all of these videos, and adhere to the deadlines. Put things where they belong and put the notes in, and you should have a 90 to 100% on that comp book. So I'm going to click under the tab of the class, or at least the video we're making right now. There are 4 things under this tab. There are things like vocabulary, practice sets, which we're going to go over right here in a minute. This video lesson will be tagged here, and notes. The way to find notes is to match up the name of the lesson, right? Well, first, let's find the semester we're in. So for this video, let's find the semester. There it is. Went flying by. This is the semester for the video we're making. This is called the table of contents. Now, you should have copied this entire table of contents into pages 2 through 6 of your comp book already. If you haven't, stop what you're doing now and go ahead and watch all the videos and do that. Put this in. This tells you where everything in the comp book goes. Now we're going to find the correct unit we're in. So here it is here, graphing linears. And then we're on lesson number 6. So these are all the lessons to this unit. Here's number 6. Linear versus nonlinear. These are the page numbers that these notes go on in your comp book. Please don't take this video's word for it, but go back and find the original table of contents. At the time you're viewing this, these page numbers probably will have changed. So now we're going to open the notes, and that's what's going to go on these pages. And it'll either be a picture of my notes from a piece of paper that I wrote my notes out on, or it'll be a picture of the board, depending on, sometimes I'll write it on the board, then take a picture and post it. So these are notes. You're going to expand them and put them on those pages of your comp books. It just explains things like a constant rate of change, what this looks like, because the graph is a line, what linear means, right? A line illustrates a constant rate of change. So a constant rate of change, we're discussing those kind of things. Increasing rate of change. The graph is a curve bending upward. So this is, the graph of a virus, which is very well known to us nowadays. This is where somebody gets sick, and then a few more get sick, and one person gets another 2 sick, and those people get 2 more sick each, right? And then at some point, this thing starts to explode up, where everybody all of a sudden is sick, and that's how an outbreak occurs with a virus. It's an exponential curve. The rate of change here is increasing. It's not a constant rate of change like a line. It's increasing its speed as it starts to spread. This is a non-linear rate of change. Okay, non-linear means not a line. It's a curve. This is the graph of the spread of a virus. One person gets 2 sick, they get 4 sick, who gets 16 sick, etc. Right? So here we have 0 rate of change. A flat line is a 0 rate of change. Right? So we're talking about rates of change now. And of course it plays back into slope because that's graphing of a line. So all of this is related to each other. Vocabulary, slope, rate of change of physical change per time, like miles per hour. Linear, a line. Non-linear, a curve. All right, so this information goes in your notes, and it will help you then do the problem sets, and it will help you understand once we get to the discussions and those kind of things, right? So is this graph linear or non-linear? The easiest thing to do, you guys, is it a line or not? If it's a line, it's linear. That's what linear means, a line. Piece of cake. All right, and just to contrast it, just like in English, you're comparing and contrasting, right? Well, is this linear or nonlinear? It's nonlinear. This is a parabola, spelled parabola, but pronounced parabola. So this is nonlinear. It's not a line, it's constantly curving, right? There's curvature going on here. If it's a curve, it's not a line. All right, and that's going to be a basic understanding you're going to hopefully carry with you as a foundation to this whole thing. Is this graph linear or nonlinear? This is a line. Linear is another way of saying a line. And this is possibly too easy of a topic, but nonetheless, students will, hear the word linear, and it doesn't always pop into their mind what they're talking about. Is this linear or nonlinear? This is nonlinear. It's a parabola again. And notice this parabola opens up. We can also have a parabola that opens down. Nonlinear is another way of saying a curve. Right? So nonlinear means not a line or a curve. All right, here's our exponential curve. This is the virus curve, right? This is nonlinear. Now, interestingly enough, look at this curve. Okay, is this linear? No, it's nonlinear. But I like that they've got points here. We're headed somewhere with this. Notice how the curve goes. It's like a roller coaster, right? Goes up, down. We go down to a trough, then up to a peak, right? All right, given the following curve, what's the name of point B? So now, look at this. We're looking at point B. Here's point B down here. So imagine you're on the roller coaster. We're at a low point here. Take this across the graph. So this would be called a minimum. That's one thing. Then there's two types of minimums. There's a global and a local. So global would be the most minimum of all the points. Is there anything lower than B? No. So it becomes a global minimum. That would make D also a minimum, but it's going to be a local minimum. So two things. You're going to have a global min. I'm going to abbreviate it min. And you're going to have a local min. Okay, and I might as well go ahead and explain this right here. Now, if you have these for mins, guess what you also have them for? You have them for maximums or maxes, right? So this one's going to be a max here. Yeah, it is. And this is going to be a max here. Okay, two different types of max. One was global. That was the lowest min. Now we need the greatest height, or the biggest max, or the highest high, right? I'm not sure how I can say that different ways. But this is going to be a global max. And then you need another max that is somewhere else in here. So this is going to be a local max because compared to these, it's a maximum. Local max. Right? So let's keep going with this. They're going to, I already explained all these. They're going to ask us, I think, C next. Let's see if the next one is what is C. And C, we said, is a local max. Given the following curve, what's the name of C? And local can be an interesting concept. It can be different for different views. If our viewing window is right here, then these two are local min and max, right? They could also be... it could change, though, if you were over here, right, and looking at just these. This could be a local min and a local max. This would still be a global max, and this would still be the global min, because those are the two most highest and lowest points. So C is a local max. D is a local min, right here. And I think they're going to ask us E, which would be a global max, we already said. All right, yeah, what's E? It's a global max. All right, so an interesting concept of, now that we have a curve, right, the straight lines are what we're dealing with now, but this is a foreshadowing into the future. What's going to happen when we get to curves, because we can only do so much with lines, and life is a lot more interesting than just lines. Life often plays itself out with curves, right? So think of the virus. Virus is an act of life, right? And that is an exponential curve. It's not a line. It's nonlinear. So when you do these practice sets, make sure you match up the title of this video with the practice set you're doing. This is Algebra 1, Semester 1. It's the third unit called Graphing Linears. It's the 6th lesson called Linear versus Nonlinear Practice, and it's on CreatorMath.com under the Algebra 1 tab. Hope this helps.